Today we're going to work on some extra examples for 7.7, which is complex fractions. Okay, so these are just some examples I've pulled out of the book, practice test, that kind of stuff. So 16 over 4x all over 8 over 4x. And if you remember, we learned two different methods. One was the keep, change, flip, which only works when you have one fraction over another fraction. And then the other one is multiplying the top and the bottom by the LCD, the least common denominator. So for this one, because it's already in the form of one fraction over another fraction, we should just use the keep, change, flip, which is where you keep the numerator, change from division to multiplication, and flip your denominator. From here, you can simplify as you go, or you can go ahead and multiply. What I like to do is write them next to each other. So 16 times 4x, because I multiply straight across for fractions, and then 4x times 8, and see if anything can cancel out. Because anything over itself is equal to 1, 4x over 4x should cancel out. If I don't see anything else right now, that's okay. I'll just do 16 over 8, and then hopefully I would see that this can simplify to 2 as my final answer, right? So another example is 4 minus 7 over x divided by x plus 5 over 6x, okay? So this one, because it's not a single fraction over a single fraction, I could not do keep, change, flip. I could not use method 1 unless I combined these two fractions and these two numbers, and I combined these two numbers. So instead of doing that, we have method 2, where we look at all the fractions in the entire problem. So for this problem, there are two fractions, right? There's this one as a fraction and this one as a fraction. And we say, what is the LCD of these two fractions? This one has just an x, this one has 6 times x. That means we're going to use the 6 times x, because I could multiply this fraction by 6 over 6 and get to 6x. Remember, I can't go down for a fraction, I can only go up for an LCD. So I'm going to use 6x as my LCD. Now what I want to do is I want to multiply both the numerator and the denominator of my big fraction, right? So this is my big fraction. So I'm going to do 4 minus 7 over x plus 5 over 6x. And I want to multiply by 6x over 6x, because again, anything over itself is equal to 1. So what I'm going to do, though, is I'm actually going to write it as 6x over 1 over 6x over 1. Okay, so this is still equal to 1, this fraction that I'm multiplying by. I'm not changing anything. But when I put it over 1, it helps me remember that I'm actually multiplying the numerator of any of my fractions, not the denominator, okay? It's really important that you remember that. Also remember that this has parentheses, so that whatever I'm multiplying out here is going to be distributed into both pieces in there, okay? So I'm going to write it out. I'm going to do 6x times 4 minus 6x times 7 over x. Okay, like I said, this is technically 6x over 1. So 6x over 1 times x for the bottom, plus 6x over 1 times 5 over 6x. Okay, now I'm just going to multiply each term individually, right? So I'm going to start with this one up here, and work my way around. So 6x times 4 gives me 24x minus 6x times 7 is 42x over x. And I'm just going to go ahead and multiply it out this time. If you feel comfortable canceling, you can do that here, but I'm going to multiply it out and show you how it cancels from there. 6x times x is going to give me 6x squared. And then I have 6x times 5, so that's plus 30x all over 6x, right? Now I'm going to simplify where I can. So I'm looking at my two fractions to see what can simplify. So my 24x is going to stay. Nothing's going to happen with that at this point. 42x over x. My x's are going to cancel. Just leave me with a minus 42. Remember that it keeps whatever sign is here. 6x squared, again, not going to change. And then I'm looking here, so my x's cancel, and 30 divided by 6 will give me a plus 5. Okay? From here, I should see if I can simplify, if I can cancel anything out, if I can factor, right? I need to factor before I can try to cancel. Down here, nothing can happen, right? There's nothing that can cancel out, so you just have 6x squared plus 5. There's nothing that can factor out of these two. Up here, you have a 2, okay? So if you took a 2 out, you're going to get 12x minus 21, right? And so this is not going to cancel. There actually probably could have taken a 6, right? Because there's a 3 in this too. But even if we take a 6 out, we'll get 4x minus 7, right? And so still nothing is going to cancel, so I don't have to actually do anything. I can just write the answer like this, and this would be a correct answer. You could write it factored also. I would not take off points if you wrote it with the factored form here, but you don't have to do that. Either answer would be acceptable. So for another example, we'll say number 3, I have x plus 4 over x minus 6 over x minus 1, all over x plus 1 over x plus x plus 1 over x minus 1. So this one is considerably more nasty, right? So we're looking at, it's not a single fraction over a single fraction, so we cannot use method 1 unless we combine the two fractions in the numerator and the two fractions in the denominator. So if we don't want to do that, we're going to use method 2, which is where we multiply by the LCD. And we're looking at the LCD of all 4 fractions, okay? So in the numerator, we have an x in one, and we have an x minus 1 in the other. So the LCD of those two would be x times x minus 1. Fortunately, the denominator happens to have the same two denominators in its fractions, x and x minus 1. So our LCD would just be x times x minus 1. Remember, you have to multiply here. You cannot add something. Like I can't just say, oh, well, this one needs a minus 1, so I'm going to take a minus 1 here. You can't do that. You have to multiply for the LCD. So please make sure you're paying attention to that. That's where a lot of people will make a mistake on this. So now what I'm going to do is multiply the numerator and the denominator by the same thing, right? I'm going to multiply by the top and the bottom by the same thing so that it's equal to 1. So I'm going to say x times x minus 1, and I'm going to put it over 1 so that it helps me remember that I'm multiplying my numerator, not my denominator, in here. And so this is one of the types of problems where you want to do it in bite-sized pieces, right? We talk about this where we're not going to try to do the entire problem at once. We are going to just look at the numerator to start with. Okay, so we're going to look at this part of the calculations to begin with, and then we'll do the second part, the denominator, after we finish this. Okay, so looking at the numerator, we have x plus 4 over x minus 6 times x minus 1, all in parentheses, right, times my x times x minus 1. So I'm going to distribute over 1 this into both of these pieces up here. So x times x minus 1 over 1 times x plus 4 over x. I'm going to actually write it as plus x times x minus 1 over 1 times a negative 6. So all I did was take this negative that was out front here and I attached it to the 6 instead. It helps for me to not make a mistake with my signs. Everybody's different, and so if you would rather leave it as minus right here, you can do that. I just prefer to keep it with my number. Okay. So this is just my numerator again. So now I'm going to multiply this, and I'm actually just going to write it all out. I'm going to write x times x minus 1 times x plus 4 all over x plus x times x minus 1 times a negative 6 all over x minus 1. Okay? And so before I try to add anything, I'm going to see what can cancel. So on this side over here, I have an x over x, so that's going to be gone. And here I have an x plus 1 over an x plus 1, so that's gone. So I'm left with x minus 1 times x plus 4 plus x times a negative 6, right? By FOIL, I'm going to get x squared plus 4x minus x minus 4 minus 6x if I go ahead and multiply these two here. Okay, so now combine like terms. I just have 1x squared, and then I have these two that are x, and this is x. So 4x minus x gives me 3x minus 6x gives me a negative 3x minus 4, because I did 4x minus x, which gives me 3x, and then I had this minus 6x, which gives me a negative 3x over here. So this is now my numerator. I can go ahead and cancel or factor right now if I want to, but we'll just wait, and we're going to go back and get the denominator. So use a different color. We'll say purple for our denominator. So if you go back up and say this was the denominator, remember, we haven't done anything with this yet, so don't forget it. And what it was x plus 1 over x plus x plus 1 over x minus 1, and we were multiplying the entire thing by x times x minus 1 over 1, right? So again, I'm going to write it all out for you guys. X times x minus 1 times x plus 1 over x, and this one's over 1, plus x times x minus 1 over 1 times x plus 1 over x minus 1. I'm going to write it out again. I'm writing a lot of steps. You may not need to do this, especially as you get more comfortable, but when you're in the beginning, it will help you to write more steps. You're less likely to make a mistake. All right, now again, we're going to look at what can cancel. We have an x over an x again. That one's gone, and an x plus 1 over an x plus 1. All right, so now when we take down what we have an x minus 1 times an x plus 1 plus an x times an x plus 1. Okay, if we FOIL this out, we get x squared plus x minus 1 plus x squared plus x. Difference of squares here, so this cancels out. I'm left with x squared minus 1 plus x squared plus x. I'm going to combine like terms. I have an x squared and an x squared. I get 2x squared plus x minus 1. And this is just my denominator. Again, remember, so we're going to come back up to the top, up here where we were working, and this was our this was our numerator, right? And this one is our denominator. So we need to write our entire fraction now. X squared minus 3x minus 4 is the new numerator, and the new denominator is 2x squared plus x minus 1. And what we need to do now is factor both the numerator and the denominator, because you can't see right now if anything would simplify or cancel out. And if you answered it as this and something could cancel out, then the computer's going to mark you wrong and say that it's not fully simplified. So we got to go ahead and factor like we did all through Module 3, right? X and an X, and we know that minus minus is going to give us a plus and a minus, and we're looking at a plus 1 and a minus 4, because that gives me x squared minus 4x plus 1 minus 4. A negative 4x plus 1x gives me the plus 3x I'm looking for. Down here, I'm going to have an x squared, or I mean an x and an x, right? That's the only way to get my x squared. And then I also have a plus and a minus, because I need a minus here and a plus here. So that's going to need to be a plus and a minus for my signs. And I'm looking at 1, right? Because it's only, the C is 1. So it's going to have to be 1 and 1 here. And you could do grouping and do it that way. This one is kind of simpler, so I'm just going to do it using guess and check. If I put my 2 here, because 2 only has itself in 1, so it also has to be 2. The 2 is either got to be here or here. If I do it here, I get 2x minus 2x. I get 2x squared minus 2x plus x, not 2x, plus x minus 1. And if I combine my middle terms, because that's what I'm looking for, I get a negative x. So this is not where I want my 2 to be, because I need a plus x. So if I take my 2 out and I put it here, do the same thing, I get 2x squared minus x plus 2x minus 1. Now combine these two and I get a plus x instead of a negative x. So please make sure that you're checking, if you are doing guess and check, to get the right factors. Now it's fully factored and we want to look and see, does anything cancel out? And in this one, yes, x plus 1 over x plus 1 will cancel. And my final answer will be x minus 4 over 2x minus 1. So you can see these problems can be pretty lengthy and they are somewhat difficult, so it takes a lot of steps. There's a lot of room for error. All right, so I have 1 or 2 more we'll do just for some extra practice to help you see these really difficult ones. So minus 2x over x minus y all over y over x squared. And sometimes the hardest part with these is trying to figure out the LCD if you need to do that. However, this problem is one fraction over another fraction, right? It's one fraction over another fraction. It's not 2 fractions. So we can go ahead and use method 1 with this, which is where we do keep, change, flip, right? So you keep the first one exactly as it is, negative 2x over x minus y. You change from division to multiplication, and you flip your second fraction, which is x squared over y. And then for fractions, we multiply straight across, so you get a negative 2x cubed over y times x minus y. You can do this one with method 2. You could do any of them with either of the methods. It's just sometimes one of the methods is easier than the other. So it will help you if you can get comfortable with both. If you find that you're making mistakes and you're mixing up the two, I would pick one method and just use that method all the time. But whatever works for you is what you should focus on. And this would be the answer here. We would stop because nothing can cancel. Even if I try to factor something in the numerator or do something, nothing's going to cancel out, so we're done. That's the end of our answer for that one. So one more, again, extra practice for you guys. So finding the LCD, because this one is not one fraction over another fraction, so we're going to choose to use method 2. We need to find the LCD of both the numerator and the denominator. What I would recommend is to start by factoring this bottom one here to see what its factors are, because right now we don't know what multiplies to give us this, so it's hard to find the LCD. If you go ahead and factor it, you have an x and a plus and a plus. 15 has very few factors, 1 and 15 and 3 and 5. We're looking for 8, so it works out that 3 and 5 is what we're looking for, because 3x plus 5x would give me 8x, which happens to be the two denominators in the numerator, which is fantastic, right? So our LCD is just that, x plus 3 times x plus 5. And when we go to multiply this, we're going to multiply both the top and the bottom by this x plus 3, x plus 5. I'm going to write it as factored in the bottom, so x plus 3 plus 16 over x plus 5 all over 5x plus 17 over x plus 3 times x plus 5. And we multiply the top and the bottom by our LCD of all the fractions. And put it over 1, so we remember to multiply the numerators and not the denominators. Here, down here we're going to look, and this one's going to cancel right off the bat. So that makes our life a little bit easier. The denominator's only going to be what's left here, 5x plus 17. Okay, and the numerator, this one, on this side here, the x plus 3 is going to cancel, so I'm left with 4 times what's left, x plus 5, plus on this one, the denominator is going to cancel, 16 plus x, or times, not plus, times x plus 3, what's left, right? So now I need to go ahead and multiply out and simplify just to make sure that there's not going to be anything that cancels or anything that happens. So I'm going to do 4 times x and 4 times 5, which gives me 4x plus 20 plus 16 times x plus 16 times 3, 48, right? Combine like terms on the numerator, because the bottom has not changed. The denominator is still just 5x plus 17. Nothing can happen down there. There's not even anything that can factor. Combine like terms, so I have a 4x and a 16, which gives me 20x. And then I have 20 and 48, which is a plus 68 over 5x plus 17. So this is where it could get sticky, because you may not see that the top is factorable. Again, if you answered this, it would mark you incorrect. It would say it was not fully simplified. I would give you back some points, but you should be trying to factor. So if you look, they both have a 4 in common, both 20 and 68. So if you take a 4 out, then you're left with 5x plus 17, which happens to be my denominator. So these two cancel, and my answer is just a pretty little 4.